9.13, identifying inverses algebraically, level 2. So remember that this is the notation for an inverse, and that we just need to swap x and y, and then solve for y. So this is going to become x equals 5 times, I think I'm going to go ahead and fix this to where it's the cube root of y minus 6. And so now it's just a process of how do I get y by itself? The very outer thing would be to get rid of this times 5 by dividing it. So I get x divided by 5 equals, I don't need parentheses anymore, cube root of y minus 6. Then I would want to add 6 after the division, so it would become x divided by 5, then plus 6 equals cube root of y. And then to make y not be cube rooted, I would do the inverse and cube both sides. So y equals x divided by 5 plus 6 all to the third power. And again, these will be multiple choice. Number 2, I have x equaling the 7th root of y plus 5 over 7. The outer function is the 7th root. That's what all of this is under. So I would want to take all of this to the 7th power and x to the 7th power. That would get rid of that 7th root. So I'd have y plus 5 divided by 7. Then I'd want to multiply by the denominator. So I get 7x to the 7th equals y plus 5. And then all I'd have to do is subtract 5. So y equals 7x to the 7th minus 5. Number 3. X equals 2 times y plus 4 to the 1/5 power. Could have went ahead and made that a 5th root. First thing I'm going to do, so that's like having 2y to the 5th minus 6. I would want to add the 6 first. So it'd be x plus 6 equals 2 times, I think I'm going to go ahead and write that all under the 5th root, y plus 4. Then I'd want to divide away the 2. And then to get rid of the 5th root, I would take it all times the 5th power. So it'd be x plus 6 divided by 2 to the 5th power equals y plus 5. And then I'd have to subtract 5 at the end. So I'm kind of running out of room here, but it would be y equals x plus 6 over 2 to the 5th power minus 5 at the end. Okay, last one like these. I would have x equals 6y cubed plus 7. I think again I'm going to go ahead and just make all this be the 5th root. Since it's all under this, I need to take it to the 5th power. So I get x to the 5th equals 6y cubed plus 7. Subtract 7. Divide by 6. And then cube root. So y equals the cube root x to the 5th minus 7 over 6. Okay, and the last thing that we need to talk about is when you have rational functions, which means there's an x in the numerator and the denominator, or more particularly an x in the denominator for sure. So f of x is going to be x. We'll have 5y minus 1. You also need to put a y in the denominator. Think about a proportion. So any whole number can be put over 1. A proportion means you cross multiply. So I'm going to take x times 2y. And then I'm going to take 5y minus 1 times 1, which is going to stay 5y minus 1. Then what I want to do is get all the terms that have a y on one side and all the terms that don't on another. And so I'm going to actually rewrite this as 2 times x times y, 2xy, because that looks neater. Then I'm going to subtract the 5y over equals -1. Then I'm going to factor a y out, just like if this were a problem that I say factor, your GCF would be the y. That would leave you with a times 2x minus 5. And then all I got to do is divide away this 2x minus 5 to get y by itself. So y equals -1 over 2x minus 5. All right, one more of those. X equals 7 minus 4y over 8 plus 3y. This is over 1. We need to cross multiply. So I'll have x times 8 plus 3y. You have to have parentheses around it to distribute that x, equals, this is just times 1, so it'll be 7 minus 4y still. I'm going to multiply, so it gets an 8x plus 3xy equals 7 minus 4y. Get the terms that have y on one side. So this does and this does. I'm going to keep the 3xy here. I'm going to add the 4y over. And I'm going to subtract the 8x over. So now it's a negative 8x plus 7. Factor your y out. So you get 3x plus 4. And then you're just dividing away that 3x plus 4. So y equals negative 8x plus 7 over 3x plus 4. And that is the last lesson in this unit.